Hello everyone. Welcome to the final lecture of the preliminary course, the rendering workshop. Let's open the project used in the lighting workshop. We will continue working on that. Rendering, or photorealistic image, is used to present a 3D model realistically to the client. Visualization is a time-consuming process, and mastering the technique can take a long time. After the completion of the ARCHLine.XP model, we have two options to create a photorealistic visualization. The first is to use the internal rendering engine, and the other is to use an independent external application. ARCHLine.XP is an open program that provides various communication options with other programs. For example, the DWG format is commonly used to transfer 2D floor plans. IFC is suitable for receiving and transferring 3D BIM models. Through the SPK, FBX, OBJ formats, we can transfer our 3D model to other external rendering programs such as Corona, V-Ray, 3D Studio Max, or Cinema 4D. We recommend using the external renderer for those who have already mastered the program and have extensive experience with it. Today's workshop will focus on demonstrating the method for creating high-quality, photorealistic visualizations in ARCHLine.XP. Let's get to work. Let's familiarize ourselves with the model. Here are the views that we have already saved. We can navigate between views using the blue arrows. Click on the name to create a new perspective in the perspective dialog. First I set the view I want, then I click on the green plus sign to save. I activate the Shop 5 view. I'll work with that. It's important to set the camera and target to the same height value between 1.1 and 1.4 meters. And the angle of view should be between 60 and 70 degrees. Deviate from these values only in exceptional cases, for example in very small rooms. Let's also see what layers this project has. I will activate the floor plan view and choose the layer walk. The client area is divided into 5 layer groups. I will talk about the significance of this later in the presentation. Additionally, we have wall and slab layer. A good photorealistic image is not created with just one click. We need to learn how to handle lights and shadows. We need to understand the physical properties of materials, find the ideal viewpoint, and set up the sun accordingly. We need to build the image step by step, and in these steps, we need to continuously create test renders. Generally, to achieve the final render, we need to create approximately 25 to 30 test renders. The number of test renders and the rendering time depend on various factors. Let's go through these factors. The first one is the size of the model, which is determined by the number of surfaces. We can check the number of surfaces using the Build 3D Model command. This project consists of 68,773 surfaces. A medium-sized computer can efficiently handle up to approximately 1 million surfaces. If the number of surfaces reaches 3 million, the program will send a warning, and if it exceeds 5 million surfaces, we will receive another warning. In such cases, it is advisable to replace high-surface objects to work more efficiently and faster on our project. The next factors that influence rendering time are computational capacity, processor speed, and memory size of your own computer. You can obtain these data by typing dxdiag in the search bar next to the Start menu and running this command. Here you can see the values for the processor and memory. The recommended values are an i7 or i8 core processor and 16 GB of RAM memory. If you see lower values here, it is worth upgrading your computer. The other two factors that affect rendering time are the complexity of materials and lights, as well as rendering settings. When it comes to rendering settings, it is important to consider the resolution and the chosen rendering preset. Now let's see how we can save rendering time. In a project with multiple rooms, it is advisable to disable the layers of those rooms that will not be visible in the render. Within a single room, it is recommended to use 3 layer groups and divide the rendering process into different phases. This way, the rendering time will be much faster compared to test renders. Now let's see what these 3 phases are. The first phase is when we only focus on architectural elements such as walls, floors, ceilings, etc. The second phase is when we include furniture. And the third phase is when we add decorative elements. Let's see how many surfaces we have in this project when we disable the layers for furniture and decorative elements, leaving only the architectural elements enabled. I will activate the floor plan view and quickly turn off all layers except for the wall and slab layers. To see the modification in 3D, I will first rebuild the 3D model and then go back to the Build 3D Model command. I will check the number of surfaces, which is now 3,594. This means that the computer has to work with a much lower number of surfaces, so the renders will be completed much faster. The next setting is the position of the sun and north. We can adjust this under the View, Sun Position menu. First, we need to select our geographical location in this project. Let's choose Budapest. Then we can select the date and time. The date should be October 7th, at 1 p.m. I won't modify the north position for now, it will remain at 90 degrees. I accept with OK. These settings will play a crucial role in the scene, so it is definitely worth paying attention to them. Let's continue with the rendering settings. When the 3D window is active, the render icon appears in the navigation bar. Here, I can select the type of rendering I want to work with. We can see that there are standalone and integrated renderings, and both have a draft mode. The draft mode means that it tracks the modifications we make in the 3D window. Let's start a standalone rendering in draft mode and explore the additional settings. As I mentioned before, the resolution and rendering presets greatly affect the rendering time. Let's see what values we can choose for the resolution. Lower resolutions than Full HD are usually chosen for test renders, while Full HD or higher values are used for the final render, which can be sent to the client. In the rendering presets, we can see the real-time draft rendering, which tracks the modifications in 3D. It generates a rough but almost instant rendered image, intended to represent an intermediate stage of work. The Q1 render is a quick preview image. It is recommended to use it at the beginning of the rendering process, at a low resolution, such as 800 by 600. With this, we can quickly create work-quality images. The Q2 render provides a clearer, better quality image, representing the next step in rendering. It is used for scenes approaching the final image at a medium resolution, around 1280 by 720. The QX render is a custom setting that can be tailored to the user's needs. Values can be individually set, based on the number of light sources, and the complexity of the model. This is suitable for creating the final render, at Full HD or higher resolutions. If we choose the QX rendering preset, we can also specify the pixel sampling and the number of render iterations. Samples per pixel refers to anti-aliasing, which smooths out jagged edges along object edges and shadows. By increasing the number of pixel samples, we can achieve a higher quality render, but it will also increase the rendering time. We recommend using values of 10 or higher for the final render or complex lighting. If the lighting is less complex or for test renders, lower values below 10 are recommended. The render pass count means that the program uses a progressive engine during rendering, refining the image with each step. Increasing this value will also increase the rendering time, but provide a much better quality image. The necessary steps to adjust greatly depend on the scene you want to render. For scenes with complex lighting, we suggest using higher values, such as 30 or above. If the lighting is less complex, lower values below 30 can be chosen. The next option we can adjust is sharper details. This option removes noise while restoring and enhancing details, making the scenes sharper. For now, let's leave this option enabled. The next setting is to enable artificial lights. This is basically a main switch to turn off the lights, if they are turned on in the model but we don't want them to illuminate the render. The artificial lighting scaling option allows us to adjust the intensity of artificial lighting. For sunlight, there are several options to choose from. Clear daylight represents undisturbed sunlight. Cloudy daylight has less dominant sunlight, as if the sky were actually cloudy, and artificial lighting has a slightly stronger impact on the scene. Sunset represents a scene captured at sunset or sunrise. Naturally, the outdoor night scene results in a nighttime setting. If we want to create a nighttime render, there are two important steps to consider. For the sunlight, let's choose an outdoor night and consider selecting a nighttime background if the scene includes an outdoor environment. I'll choose cloudy daylight for now. Here you can see the date and time we set earlier. In the next step, we can also select the background. It can be a solid color, gradient, image, or panorama. There are several options for images, and we can also specify a custom background. For panoramas, there are 3 options to choose from, and we can also download a custom panorama from the internet with the HDR format extension. I'll choose an image with a cloudy city sky for now. The next setting is the output path for the rendered images. Here we can specify where the program should save the images we create. The last point is the background brightness. Here, we need to enter the values in reverse. Use 5 for darker nighttime scenes and 100 for brighter daylight scenes. I'll choose this setting, and before starting the rendering, I'd like to show you the render frame. I'll close it. I'll enlarge the 3D window to demonstrate the purpose of this function, then go to the View menu, Rendering, and set the render frame. A green frame appears, indicating the portion of the scene we will see when rendering at the chosen resolution. Anything outside this green frame, marked in gray by the program, will not be visible in the render. I'll turn off the render frame and return to the rendering. Before we continue with our work, let's check if the lights placed in the suspended ceiling are turned on. I select the ceiling and in the Properties menu, under the light, I turn on the lighting so that it will illuminate in the render. I'll start a standalone render in draft mode. I turn off the Enable Artificial Lights option. Click on the Render button to start the rendering. At the end of the rendering or when it is interrupted, a denoising module runs to remove noise from the entire scene. This will provide a much cleaner image for us to make the necessary adjustments to the model. Let's take a look at the sunlight, for example. It's fully coming into the space. I would like to make it much subtler, and not dominate the scene to this extent. Let's save the render image. I'll minimize this render. The rendering can be easily accessed on the taskbar. I use the sun and shadow simulation to modify the position of the sun. I can reach the same setting in the dashboard. I can adjust it with the sliders or manually. I will choose July 12th, 3 p.m. I can adjust it with the slider. I'll choose July 12th, 3 p.m. I'll go back to the render, and the program will start modifying the render accordingly. Now the sun is not as prominent, so we're done with this adjustment. I'll save it in the Preliminary Course, Rendering folder. Let's continue working with the phases. As mentioned at the beginning of the video, we will work in 3 phases. In the first phase, we will focus on architectural elements, in the second phase on furniture, and in the third phase on decorative elements. Within each phase, we will perform 3 additional steps. The first step is to apply render styles to the surfaces and then create a test render. If anything is not satisfactory, we will fine-tune the materials. Let's see how we can do this. In the Design Center, under Render Styles, we find 21 render styles for the main material types. These can be dragged and dropped onto the surfaces. For example, we drag the parquet render style onto the floor, the wall render style onto the wall, and the ceiling render style onto the ceiling. Applying render styles to surfaces does not change the size of the materials, only their material properties. Another thing worth noting is that each render style has a color code in the top right corner. This helps us verify which render style is applied to which surface. So, if I click on the color codes, the program displays that specific render style with the corresponding color, allowing us to check if we've done it correctly. The reset option can be used to revert to the original state. Let's start a draft mode render in a separate render mode, and see what changes we achieved with the render styles. It's done now. Let's save it, and compare it to the first render. We can see how applying rendering styles to certain surfaces can make a big difference. The ceiling has become whiter, the wall has become much brighter, and the floor reflects more. However, there are parts that need to be fine-tuned, in this example the walls and the floor. Let's create another render by turning on artificial lights, and save the image. Next is the fine-tuning. This is already the third step within a phase. The first is applying render styles, the second is starting a test render and visually inspecting it, and the third is fine-tuning the materials if necessary. We can do the fine-tuning in the 3D window by clicking on the respective surface and selecting the Material Search command. The program provides information about the material applied to the surface and its properties. Here, we can see that we set the parquet render style. The material can be brightened or darkened with brightness. The default value is 50, dragging the slider to the left darkens the material, and dragging it to the right lightens it. Metallic is used to adjust the reflection of the material, and roughness is used to adjust the reflection blur. We can also add bump map to materials, either by texture or by selecting built-in textures. We can also set softness for these. For some materials we can also adjust transparency. For the parquet, set the reflection to 50% and the roughness to 0. The changes are immediately visible in the 3D model. I also change the material of the wall. I set the reflection to 1%. I do the same for the blue wall. Let's start a new draft render with the new settings. We can see that this gives us a much smoother result. We can save this. Let's compare the two images. The right one is the most recent one we created, and the left one is the one before we fine-tuned the materials. It's clear that the parquet floor reflects much more beautifully, the wall has become brighter, and the ceiling has whitened. Fine-tuning the materials makes a significant difference. Start a better quality render in this state, where we can check the material settings even more accurately. I choose the Q1 render preset, and the resolution should be 1024 by 768. Let's start rendering. This will take a bit longer, as we'll be rendering a better quality render. I've also saved this render image. Let's continue with the next phase. Activate the furniture layers after switching to the floor plan view. Let's rebuild the 3D model. I suggest trying out different render styles for each surface, because it's possible that a render style looks different on each surface. For example, let's apply the metal render style to this countertop, and see how it looks in a real-time draft render. If we stop the rendering, the program still cleans up the image, allowing us to create draft renders much faster while still seeing the result. This render style gives the furniture a reflective, metallic surface. Let's try out more render styles. Let's check out the plastic. I'll wait a bit for the program to load, and then I'll stop the rendering again. Even like this, it looks very shiny. I'll apply the marble render style to the furniture. I think that will be good. I'll go back to rendering, and this time, I'll wait for the final result. The reflections are now suitable for this piece of furniture, so I'll save it. Now I'll show you how to easily replace a material on the 3D model. From the Design Center, I'll locate the chrome mirror material and use the drag and drop method to apply it as a painting. As a standalone rendering, I'll start a real-time draft render. Let's see what kind of image we get this way. It's immediately apparent that the wall surface is indeed reflecting. I'll continue with the third phase. I'll restore the normal wall style to the wall. In the floor plan view, I'll activate the client area decor layer, then rebuild the 3D model. I'll zoom in on the computers and apply the real emissive render style to their screens. This will give them a glowing effect. Now, I'll create a standalone render. The render is done, and we can see that the screen really appears to be glowing. Now I'll activate all the client area layers and the lighting layer. I start a standalone render with Q2 render preset and 1280 by 720 resolution. This render takes a bit longer, but it's worth waiting to see if we have chosen the right material settings for each surface. The render is complete, and now let's check the effect settings. Let's start with the exposure. It's important to adjust these values in small increments. The exposure helps to ensure that white colors appear truly white in the scene and that there are no overexposed areas. In this example, we should consider the ceiling. Adjust the brightness and contrast a little. Double-click on the small icon to reset to the original value. With saturation, we can enhance or desaturate the colors in the render. The shadows, midtones, and highlights always affect a single value. With shadows, we can lighten the darker areas, as can be observed with the darker object on the table here. The midtones will lighten or darken the midtone surfaces. I'll restore it to the original value. With highlights, we can darken the brightest points in the render. White balance allows us to create a cooler or warmer scene. I'll leave it at the default setting for now. Instead of exiting the render window, let's modify the render resolution in the top right corner. I'll set it to Full HD, which means I'll use a resolution of 1920 by 1080. In the middle, we can find the views. That's why it's worth saving multiple views within a project, so that we can choose which view to render within the render window. In the Details tab, we can select which render to launch. Now we can start a QX, Custom Settings Render Set. In this case, we can adjust all the values just as we did when starting the render. I'll leave the pixel sampling and the render pass count at their default values and don't change any other settings for now. Let's check the Sharper Details option. Currently, we can see that all our details are sharp. If I disable it, we'll get a slightly blurrier, more subtle result. I'll restore it now. Let's start the render by clicking the Start button. This render may take more time, possibly up to 60 minutes, as we are working with the largest render set and full HD resolution. Let's move on to the last menu item, the list. Here, we can see the views we saved in the project. If I stop the rendering, these options become active. If we stop the rendering before it reaches 50%, the program will automatically ask if we want to use noise reduction to improve image quality. If we answer no, the rendering process stops immediately. Now I'll select yes, so the noise reduction will be applied. Therefore, the views have become active, and if we check a specific view or multiple views, the program will render them sequentially. The ones with a green checkmark are finished. It's important to note that we can independently set the settings provided on the Effects and Details tabs for each view. This allows us to assign different backgrounds to different views, for example. The clock symbol indicates that it's waiting, meaning the rendering process will occur one after the other. I've stopped this render and won't save it. Now, let's take a look at the renders that have already been completed and can be found in the preliminary course folder. Let's summarize what we learned during the workshop. As we have seen, creating a good photorealistic image requires several steps. Let's sum them up. First, let's use at least 3 layer groups per room. Set up at least 2 or 3 perspectives that effectively showcase the scene. When setting up the perspective, the object and camera values should be between 1.1 and 1.4 meters, and the camera angle should be between 60 and 75 degrees. Adjust the position of the sun so that it's not too contrasted and doesn't dominate the entire scene. Start a test render and work in 3 phases. The first phase is when we work with architectural elements. The second phase is when we work with furniture. The third phase is when we work with decorative elements. Within each phase, work in 3 steps. The first step is to assign appropriate styles to the surfaces. In the second step, start a test render and observe the materials. In the third step, fine-tune the materials. Adjusting materials requires a lot of experimentation. Find the harmony between the lights and sunlight. Start with sketch renders at the beginning and then switch to a Q1 render at a lower resolution, followed by a Q2 render at a medium resolution. If everything looks good on these renders, then move on to a QX render at Full HD or higher resolution, which will be the final render. Set up custom settings depending on the complexity of the light source and the scene. Rendering can take up to 60 minutes at this stage, depending on various factors. Once the render is complete, use effects to make the visualization more lifelike by adjusting values such as brightness, contrast, saturation, and white balance. At the end of the process, enable the Sharper Details function. By enabling this, we will achieve an impressive effect and be able to create much sharper, more detailed images. Those who follow what they have learned during the workshop will be able to create high-quality photorealistic visualizations. However, rendering requires a lot of learning and experimentation, so it's worth practicing and experimenting with material settings and rendering. Thank you very much for joining me today. Have a great day. Goodbye.